We resist too much, you might get a squeak. You're not going to get much sound out though, or you might get static. You don't resist enough, you just get air. You don't get any sound. I want to demonstrate some of these principles of vibration first before we dive into the embouchure on other instruments and other types of vibrating materials, so that it can maybe in a way illustrate what we're trying to do on the trumpet in a more common level ground kind of way, that we can look at it across the board and say, hey, you know what? All instruments create vibration. So one of the things we can do right away is to look at a couple different instruments, as I mentioned, and see what the common denominators between all of them are in terms of creating vibration. So if we look at this hand drum right here, notice that it gets a really easy, immediate sound. I don't have to work very hard. It's set up for success. And the three things that are making this thing set up for success are the same things that are going to be helping us for the trumpet. They also help the guitar to sound good, and the saxophone and a lot of other instruments. I'm going to demonstrate a couple of those things for you right now. If you notice, the skin of the drum, although I think this is plastic, sometimes it's with an animal skin, it's taut. It's made to fit onto the drum in a way where there's no wrinkles in the material. It's completely pulled at every end over this rim so that it has tautness, right? That allows for the vibration to happen seamlessly through the material from one end to the other. There's another quality to this, which is that it's attached very, very well all along this perimeter, precluding any vibration from going past this point. We want all the vibration to happen only right here. And of course, it's resonating through here, which is where the air column, and that's the third thing we're going to be talking about. We need air to carry vibration. Let's list those things one more time. We have the tautness of the vibrating material. We have the attachment of the vibrating material, which precludes vibration on one end, but maximizes vibration where it's supposed to be. And then we also have the air, of course, which is going to carry that vibration to our ears. So if we listen to on that, we can kind of get another sense of how that's playing out on this little thing right here. This is I believe it's a Barry saxophone mouthpiece. Well, how did I make a sound on that thing? Well, let's look, how are those three principles applied to this? We have attachment right here. The ligature is holding the reed, right? We can't stretch or make taut the reed, but we don't need to, because the reed is inherently already got rigidity to it. If you notice, it's a piece of cane, and it's carved thicker to thinner, which is allowing variances in terms of the pitch that we can get. We're not going to get into how to play saxophone, but I can assure you that the same thing that we get from tautness is already inherent in the rigidity of that reed. There's another thing, of course, which is airflow. If you look here, there's a little gap between the reed and the actual mouthpiece itself. If the reed was like that and attached and air couldn't pass through, we wouldn't get any sound out of it. We have to have airflow. Of course, it's a wind instrument, so that makes sense. But we take this, we don't think of a guitar as being a wind instrument, do we? But yet it needs air to vibrate, just the same way that a trumpet does, or that a saxophone does, or that a drum does. If I pluck this string, we can look and see right away from the bridge up to these tuning pegs, there's definitely some tautness in the way that this string is positioned. If we were to detune that string to a point where it gets flabby, it's going to get a pretty bad sound and eventually no sound at all. That's the same on the drum. And it's even the same on the reed if we start to detach, right? So we have to have that attachment. We see that principle's here. We see that tautness is there. And if you notice, the strings have to be high enough off of the neck right here so that the string can actually vibrate. If the string was too close to the neck or to the frets, we would actually hear some disturbance and noise, right? So let's keep in mind all these things that we talked about, these three principles of vibration, and think about how that could apply to a trumpet, to a mouthpiece in particular. When we take our lips and we mate them to this mouthpiece, it's much kind of the same thing as what's happening here. If I look at this mouthpiece here without a reed, and I say, hey, play on this, you'd say, that's crazy. There's no reed in there. It's not complete. It's the same thing here. A mouthpiece is just a mouthpiece. The lips, that's our reeds. We basically play a double reed instrument. And if you think about positioning these lips on this mouthpiece, much the same way that that we position the head of the drum, or the strings on the guitar, or the cane reed, that's how we're going to get success. We have to figure out the right way to position these on this so that they can accept airflow and they can give us those three principles of vibration, right? Tautness, stability, and of course air to carry sound. So we're going to dig into that and go through all of those. But before we do that, I want to show you something really kind of fun. So here's another instrument that you might not have thought of. This might be in your backyard or your front yard or your neighbor's yard. It's a piece of grass. And with a piece of grass, I learned this trick. I can't even remember when I learned it, but I remember somebody showed me, hey, if you position this like so, you can get a sound. Well, what is that like so? What am I doing here? If you look, I position it at the base of my palms, and then I position my thumbs in a way where I can grab that piece of grass and then gently stretch it up to create that tautness. So we have attachment, stability of that vibrating surface, and then we have the tautness of that surface. Oh, here we go. And then airway, you can see there's a space there. And then if we get it just right, and you're probably gonna have to play with this a bit, we can start to get a sound out of it. And sometimes you can get a really powerful sound. It all depends on the blade of the grass and how well you position it in your hands. And sometimes you can actually pull a little bit tighter and actually the sound will go a little bit higher. Another way you can do this is simply hold it taut between your lips and gently blow. Notice that if I don't hold it taut, no sound, right? This material was not ready to vibrate. This is really important to make sure that the material has a readiness to vibrate. I took the liberty of actually putting a synthetic reed on my trumpet just to see if it would work. I remember hearing this story by a great teacher. His name was Philip Farkas. He actually kind of wrote the book on embouchure. So if you're watching this video, I suggest that you all check out this book as well. It's called The Art of Brass Playing. And it's a book, I believe it was written in the 50s, but it's still, to this day, one of the best treatises and scientifically written materials on the embouchure that's ever been written. And I frequently go back to that book. And I remember one thing he said in the book was that one way that a student would inevitably or invariably find out how the embouchure works is to try to create one synthetically. And I never did that, right? The idea of actually, like, how would I build a trumpet embouchure? Not your lips, but look at that. In fact, if you can hear that, kind of sounds like a drum. What did I do here? I actually took some silicone from one of these little toppers that you can put on top of a Tupperware. Put it in the fridge, keeps your food fresh. I sliced it up, much to my wife's chagrin, and I put it on the mouthpiece, and found a way to get the material to kind of have that drum-like quality, but then also it needs to have airflow. So if you look, I actually kind of put two pieces and have them slightly overlapping so that they can touch and create vibration, but the airflow can still go through there. And lo and behold, what Philip Farkas said is pretty true. I had to get the tautness, I had to get the airflow, I had to get the stability, which is thanks to this little rubber band right here. And if I go to blow through it, and what's interesting about this is I'm not using my lips at all, and it still sounds like a trumpet, but kind of something between a trumpet and maybe one of those bike horns. But let's take it off. See what an actual embouchure sounds like. So now that I have that taken off the mouthpiece, There's definitely a lot more character in the way that the lips produce the sound. However, I'm still using all the same fundamental concepts that I just talked about in terms of the principles of vibration. You know, making sure that the lips have a certain tautness, making sure that they have a connection, and of course, an airway. So, with that all being said, I want to dive in and talk about how we can construct a really great embouchure that's going to get you off on a great foot, whether you're a beginner or maybe you're a seasoned pro and you're looking to get more efficient and get a better setting and maybe just learn more about the embouchure. So let's get to it.